In the last video, we discussed how the three different forms of a parabola give us different information. In this video, we're going to focus on vertex form, which we should be able to identify the vertex just by looking at. Remember, we flip the sign for the x, but then the y is right there, just like point slope form of a line. The other thing we need to remember when we're graphing it from vertex form is how to decide whether the parabola opens upward, like makes a U shape, or whether it is downward, upside down parabola. And that is all up to the a value, whether the x squared, the leading coefficient, is positive or negative. So if a is positive or greater than 0, then it'll make a right side up parabola. If a is negative or less than 0, then it's going to be upside down. And if a equals 0, then it's not a parabola anymore. It becomes a straight line. All right. Oh, the other thing we need to recall is the axis of symmetry is a vertical line. So x equals a number is an equation of a line. In this case, it's x equals whatever the x value is from the vertex. So that's the vertical line that will cut the parabola in half. All right, so let's try some of these. So this is an equation in vertex form. The a, the number in front of the parentheses, is just 1, and that's positive. So a equals 1, which is positive, so it's going to make a regular right side up parabola. The vertex, remember we flipped the sign for x, so it's going to be positive 3 for x, positive 2 for y. Now we don't got any grid lines for this, so let's just sort of make our own scale, try to be, somewhat decent with like making each tick mark be the same amount. So the point 3, 2 is right here. And then we know it's going to go upward. The other thing we might want to know is its intercepts. Right? Now this is not in factored form, so it's not, clear what the x-intercepts are, or it's not in standard form, so it's not clear what the y-intercept is, but we're still allowed to plug in 0. And this one won't have any x-intercepts because we know it's going to go upward. We want to find where it crosses the y-axis. So for the y-intercept, I'm going to plug in x equals 0. So for this equation, it's in function form, so I'm going to call it f of 0 is 0 minus 3 quantity squared plus 2. This is negative 3 squared makes 9 plus 2, so that would be 11. All right, well, I better start counting to 11. So that was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll say is right there because this was 2. So that makes it more clear that it's a pretty, I don't know that I'd call it a skinny parabola, but it's not super wide either. All right, and let me label that point 0, 11, because that was our y-intercept. Oh, and I should label, yeah, I put it over there too, but always make sure that both your vertex and any intercepts are written as points. Yeah, let's label that vertex too. Let's make it look pretty, 3, 2. Because we reviewed axis of symmetry, if we wanted to put that, the reason I knew how to draw this, the other side of the parabola, is because I knew that it was symmetric around this line x equals 3. All right, that pretty much covers it, I think. Let's try another one. So this one has a negative a value. So if a is negative 0.5, that means it's going to be an upside down parabola. The vertex, we flip the sign for x, so it's positive 4, same y value. So let's plot that point. So we're going to go over 4 for x, up 2 for y. And I know it's going to be upside down. Let's do the same thing we did last time where we find at least the y-intercept, right? Because there's going to be 2 x-intercepts. We could find them, but let's instead focus on at least the y-intercept, since that should be easier. The y-intercept, we plug in x equals 0. So f of 0 is negative. If you don't like the decimals, I think I'm going to call it negative a half. In my head, it's easier to divide by 2 than it is to multiply by 0.5. So I'm going to write it as a fraction. Then 0 minus 4 squared plus 2. So this is 16. Half of 16 is 8. So that'll be negative 8 plus 2, which is negative 6. So I need to go down 1, 2, 3, 4, 5, 6 to negative 6. That will be where the y-intercept is, the point 0, negative 6. Now, if we use the axis of symmetry, so the axis of symmetry is the line x equals 4, I can figure out that there's another point over here, and that might be enough to, draw something decent. We could also, set this equal to 0 and find the y-intercepts or the x-intercepts. Let's go ahead and do that, and let's see how decently I graph this. So for x-intercepts, we need to let y equal 0. So in this case, that's the f of x. So 0 equals negative 1/2 times x minus 4 squared plus 2. So I would subtract 2 from both sides. So negative 2 equals negative 1/2 times x minus 4 squared. I have to multiply by negative 2 to cancel the fraction. So that would be 4 equals x minus 4 squared. Ooh, well, to undo a square, we have to square root. And that's when you have to put plus or minus. Yeah, that's why I sort of hesitated if I really wanted to do this, but it is not that bad, and it's a good review to do. So now we have x minus 4 is either positive or negative 2. So when I add 4 to both sides, we have 2 answers, either 4 plus 2, which is 6, or 4 minus 2, which is 2. So our 2 intercepts should be at 2 and at 6. Now, not exact, but we did pretty okay on this graph up here. So the 2 intercepts are at 6, 0, and then this is 2, 0. Our vertex is at 4, 2. And then I sort of already labeled the y-intercept here and put it there as well. So yeah, I should write these as 0.6, 0 and 2, 0 are the x-intercepts on this parabola.